Square root property part 2. We are still going to be isolating our squared term first, and I'm going to be denoting the squared terms with green squigglies underneath them to help you see them more clearly. So we're solving quadratic equations, and when we solve quadratic equations, we are anticipating two answers. So here we go. 1/2 x squared minus 25 equals 0. Isolate the squared term first. The squared term is x squared. So the first thing we're going to do is use an inverse operation to undo plus 25. And what undoes subtraction? Addition. Plus 25 on both sides. Try to keep those equal signs lined up. 25's cancel. We get 1/2 x squared equals 25. Next thing we need to undo is a times 1/2. In order to undo a fraction that has been multiplied, we need to use the reciprocal. The reciprocal of 1/2 is 2/1 times 2/1. Remember, 2/1 is the same thing as just 2. 2's cancel, and we end up with x squared equals 25 times 2. That's 50. So we only had one problem like this in the last video, and it was actually ended the same way as this one. If we have x squared equals 50, we're going to use an inverse operation again to undo a squared term, and we can undo a square with a square root. So we have the square root of 50. So let's go ahead and start by making a factor ladder for 50. I'll start with 5. 50 divided by 5 is 10. 10 divided by 5 is 2. So 50 is equal to 2 to the first times 5 to the second. This is the prime power factorization, and we're going to replace the 50 with it. So the square root of x squared, hooray, it's x. That's exactly what we're trying to do, solve for x. So from here, remember, we're looking for two answers. So it's going to be the square root of 2 to the first, 5 squared. And when we're solving quadratic equations, a very easy way to denote the principal root as well as the negative root is to use the plus minus sign. That is showing a positive answer as well as a negative answer. So now let's simplify the radical. Remember, to simplify the radical, we're going to divide the powers by the index of the radical, which is 2. So 1 divided by 2, can't do it. That is why the 2 to the first power stays under. But 2 goes into 2 one time. That is why 1 power of 5 is coming out. So these are our answers. X equals 5 square root 2, positive 5 square root 2, as well as negative 5 square root 2. You can denote that very easily with the plus or minus sign. That's what that little sign means. It means plus or minus, or positive or negative. That's what the plus minus sign means. But how many answers did we just get? 2. We got 2 answers because this is a quadratic equation. In our next lesson, we're going to see how these answers relate to the graph. But we shall keep going with a few more examples. Solve the quadratic equation. Step 1, isolate the squared term. I've already got it designated here with a little green squiggly underneath. So 100 minus 5 times x squared equals 0. We need to start by undoing the positive 100 that has been added to the left side. So we're going to use the inverse operation of subtraction, and we are going to subtract 100 from both sides. Keep your equal signs lined up, work down the page. Hundreds cancel. Remember to keep that sign. What do we have left on the left? Negative 5x squared equals negative 100. 0 minus 100 is negative 100. Next, undo the times negative 5. The inverse operation of times negative 5 is division by negative 5. Negative 5's cancel, and we get x squared. So x squared equals negative 100 divided by negative 5. Negative divided by negative is a positive, 20. X squared equals 20. Continue with an inverse operation. The inverse of squaring is to take the square root. So we're taking the square root of both sides. The square root of x squared is x, and the square root of 20. Let's make a factor ladder. 20 divided by 2 is 10, divided by 2 is 5. So this time we have the square root of 2 squared times 5 to the first. Remember, this is a square root. Its index is 2. We don't actually have to write that index because the radical sign without any given index is understood to be a square root. So, what does x equal? X equals positive or negative. That's the quickest way to show both answers. The square root of 2 squared is 2. 2 goes into 2 one time. 2 will not go into 1. That is why the 5 remains underneath. So our solutions, both of them, x equals positive 2 root 5 and x equals negative 2 root 5. Two solutions because we're solving a quadratic equation. Next example, still solving, still using inverse operations, still first isolating the squared term. The squared term here is x squared. So we need to undo a minus 60. The inverse operation of subtraction is addition. So we can add 60 to both sides and get 2/3 x squared equals 60. Let's try to keep our equal signs lined up and work down the page. Next, we're going to undo times 2/3. As we've already seen, let's use a reciprocal in order to undo that fraction. The reciprocal of 2/3 is 3/2. So times 3/2 times 3/2. 3's cancel, 2's cancel. There's our x squared. Our x squared is equal to what? Well, let's think about this. Let's put that 60 over 1. And actually, I'll even come over here and let's change that 60 to be 2 times 30. And then we can very easily see that the 2's will cancel and become the identity 1. So 60 over 1 times 3 over 2, when we cancel those 2's, we're left with 30 times 3. 30 times 3 is 90. 60 times 3/2 is 90. Remember, 3/2 is the same as 1 1/2. So 60 times 1 is 60. 60 times 1/2 is 30. So 60 times 1 1/2 is 60 plus 30, 90. So we've used inverse operations to get the squared term by itself. And now we are going to undo the square by taking the square root of both sides. So the square root of x squared is x. The square root of 90. Let's make a factor ladder for 90. 90 divided by 3 is 30. 30 divided by 3 is 10. 10 divided by 2 is 5. 3 times 3 times 2 times 5. So underneath our radical, we have 2 to the first, 3 squared, 5 to the first. Index of this radical is 2 because it is a square root. This is a quadratic equation. We will be getting 2 answers, so we can denote that with a plus minus sign. 2 will not go into 1, so the 2 stays under. 2 goes into 2 one time. 1 power of 3 comes out. 2 won't go into 1. The 5 stays under. So now we are left with plus or minus 3 square root 2 times 5, 10. That's both of our answers. This is a quadratic equation. X equals positive 3 square root 10 and x equals negative 3 square root 10. Two answers when we solve a quadratic equation. Next example. Solve the quantity 2x plus 1 squared. Now notice that I have put a squiggly green line under that entire quantity 2x plus 1. That's because all of it is inside the parentheses and everything inside the parentheses is being squared. Therefore, 2x plus 1, that binomial is the squared term. So our squared term is already isolated. So if we look back, after we got our squared term isolated, we took the square root of both sides. We need to do exactly the same thing here. To undo that square, we need to take the square root of both sides. Remembering that square root has an index of 2. So look at the magic that happens when I take the square root of both sides. This square root will undo this square, leaving 2x plus 1, completely free of that exponent. Once again, this 2, this square root, this index of the radical is going to cancel with that exponent. 2 goes into 2, 1 whole time. Goodbye radical, goodbye parentheses. On the right-hand side, and yes, I'm still trying to keep my equal signs lined up, the square root of 25 is positive or negative 5. Remember, we're after 2 answers. We're after 2 answers here. So when we take that square root of 25, we must consider its principal positive root as well as its negative root. So now we've got 2x plus 1 equals positive 5. Or 2x plus 1 equals negative 5. This is where our two solutions are going to come from. So here goes. 2x plus 1 equals 5. Minus 1, minus 1. 2x equals 4. Divide by 2, divide by 2. X equals 2. First answer. Second answer. Minus 1, minus 1. 2x equals negative 6. Divide by 2, divide by 2. X equals negative 3. Second answer. Our solution set is x is 2 or negative 3. Quadratic equation, 2 answers. We isolated the squared term first. Next, same situation. Gonna move faster. Already showing you the squared term. Once again, it's a quantity. We're gonna undo the squared term by taking the square root of both sides. The square root and the square are inverse operations. So the square root of 4x minus 3 squared is 4x minus 3 equals the square root of 64. The square root of 64 is plus or minus 8. Set up two equations. 4x minus 3 equals positive 8, or 4x minus 3 equals negative 8. Solve for the two solutions. Plus 3, 4x equals 11. Divide by 4, divide by 4, x equals 11 fourths. Do not panic if it's a fraction. Just leave it. No decimal, no mixed number, just leave it. 4x minus 3 equals negative 8. Plus 3, 4x equals negative 5. Divide by 4, divide by 4, x equals negative 5 fourths. Again, fraction, no problem, just leave it. Our solution set contains 11 fourths and negative 5 fourths. Last example. 1/2 x minus 2, the quantity squared. Again, the squared term is already isolated. I'm showing you that with the green squiggly line. We're going to use the inverse operation of squaring, which is to take the square root. The square root undoes the square, so we will be left with 1/2 x minus 2 equals the square root of 9, its positive principal root, as well as its negative root, 3. So 1/2 x minus 2 equals plus or minus 3. So that's 1/2 x minus 2 equals positive 3, or 1/2 x minus 2 equals negative 3. Solve the two equations for x to get our two answers, because this is a quadratic equation. Plus 2, 1/2 x equals 5. How do we undo a times 1/2? We use the reciprocal, times 2, x equals 10. Again, plus 2, 2's cancel. 1/2 x equals negative 1. Undo the times 1/2 with a reciprocal, times 2, x equals negative 2. Our final solution set is 10 and negative 2.